Hello everyone. In this lesson we will continue to learn about Git. So we have two main goals in this lesson. Number one, we want to grow our Git vocabulary. This just means we will learn about key terms and phrases that are used quite often in Git. And our other goal is to simply see Git in action. So I will share my screen and I will walk through a real-world example of using Git. All right, so let's get started. Here on my desktop, I have a folder named Most Advanced Site. It's a bit of a joke name. All that it contains is a single HTML file, a CSS folder with one CSS file. Okay, so here's what that looks like in a web browser. And let's imagine that the CEO of this amazing company and website has asked us to remove this line of text that says single page and to make this header orange. So in our text editor, we would simply open up the HTML file. We would delete that line of code that says single page. In the CSS file, maybe we'd add a rule that says target the H1, color orange, save it, refresh it. All right, so this is nothing new. This is not exciting. What we want to see is how Git comes into the equation. We know that Git can track changes made to our project files, so how do we make sure that the changes we just made get saved into Git's history? To answer that, we're going to take a quick vocab timeout. Okay, so first off, in Git, we don't call something a project, we call it a repository or a repo. A repository is where Git saves all of the data, all of the history, all of the changes that it tracks for a particular project. Okay, our next term is the working directory. The working directory is simply the folder location on your computer where your project lives. So in this case, we had a folder on the desktop named Most Advanced Site. This is the working directory for this repository. So Git's job for this repo is to track any changes we make to any of the files within this folder. Okay, so our next term is commit. What is a commit? Well, Git doesn't save or store changes we make into its history until we actively commit those changes. You can think of a commit as a secondary save, right? So in our text editor, when we edit a file, we save it. We hit Command S or Control S, or we go to File Save. And that saves the files to our hard drive like normal. But with Git, nothing gets saved into Git's history database until we make a commit. Now, we will commit our changes in just a moment, but first, there's one last term we need to learn about. And that term is staging. In Git, before we are allowed to commit changes, we first have to stage our changes. So what does that mean? Well, I like to think of real estate. Sometimes before you can sell a home, you first have to stage the home. Staging just means getting something ready or preparing something. Now in Git, staging is our chance to have fine-grained control on what we are committing. Here's an example. So let's say we are working on a larger project and we have made edits to 12 different files. Maybe we were experimenting and trying new things with code, but we only want to commit 4 of those files into Git's history. Maybe in the other 8 files we made mistakes or we realized that those files weren't even necessary. Whatever the case, the point is that we don't always just want to push every change we've made into a commit. So staging is our chance to say, you know what? I don't want all of these. I only want this file, this file, this file, and this file. Those get moved into the staging area. I take a second to review what I've staged. I'm happy with it, so I commit those staged files. Okay, so now we've covered all of the terms that we needed to learn. Let's get back to sharing my screen and actually committing the changes we made to this page. All right, so in order to tell Git which files I want to stage, I'm going to need to do something that might seem a bit scary at first. I'm going to open my terminal, also known as the command line. Every computer, whether you're running Windows or Mac or Linux, has a command line. The command line is simply a place where we can type commands. Now, some of you are thinking, is this really how we need to interact with Git? Isn't there an app or a program that would make interacting with Git easier? Well, this lesson is neither the time nor place for that conversation. In our next lesson, I will try to convince you why using Git from the command line is in your very, very, very best interest. Also, in this lesson, I don't want you to worry about trying to follow along step by step on your computer, and I don't want you to worry about trying to memorize each individual little step. In our next lesson, I will help you install Git on your computer. I will help you find a command line on your computer. And we can walk through all of these technical steps at a much slower pace together. But in this lesson, I want you to sit back a bit, relax, and just try to observe the general flow of what's going on. Don't worry about memorizing everything. All right, so first, I want Git to give me a recap of what I've changed lately. So if I type Git and then a new word, status, Git status, Git lets me know that these are the two files that have been modified. Okay, so I know that I want to stage both of those files. Okay, so instead of having to pick which files I want to stage, I can just say git add. I want to add to the staging area. Git add -a. This will add all changes to the staging area. So now if I run git status again, Git tells us that, okay, here are your changes that are ready to be committed. These are the files that I had in mind. So this staging area looks good to me. I'm ready to commit it. So I just type git commit, and it's always a good idea to include a message with your commit. So I'll type -m and then a bit of a quote, and I will say made the header orange and removed a line of text. And we've successfully committed those changes into Git's history. The reason this is so nice is now, even if in the middle of the night, our cat sneaks onto our laptop and deletes all of our code and says, ha ha ha, cats rule, and they erase our CSS file and just say purring and sitting in the sun. Okay, and we refresh and our hard work is gone. All we need to do is come into our command line and type git checkout, and our files are right back to the state that they were in when we made our last commit. And even if your cat is especially evil and deletes your files outright in the middle of the night, moves them to the trash, and your cat is even intelligent enough to empty your trash, and even close out your text editor, Git has still got us covered. So we just go over to the command line, git checkout. The files are restored. Okay, so now we know that the files in our repository are cat-proof, but are they disaster-proof? Meaning, if we accidentally threw our laptop into a pool of water or off the side of a cliff, would we be able to still access the files? Let's answer that question right now in the final section of this lesson, titled Push and Pull. Okay, so Git stores all of its history data in a hidden folder in the root of your Git repository. So, for example, in the project that we've been working on in this lesson, this most advanced site folder, Git actually has a hidden system folder that we can't see right now. And in that folder, it stores all of the commits, all of the changes, all of the history for our repo. Git stores all of this locally, meaning on your computer's hard drive. Now, if all of this data is only on your hard drive, that means a few things. Number one, if your computer blows up, your repository is completely lost. And number two, collaborating with a team of others is going to be pretty difficult considering only you have access to your computer. Now, we can solve both of these issues by hosting our Git repository on a server somewhere. This is exactly what the popular service named GitHub offers. There's a good chance you've heard of GitHub before. And really quickly, I want to point out that Git does not equal GitHub. GitHub is just one of many, many, many services that can host your repositories. GitHub just happens to be the most popular service, and it's also the one that we will be using throughout this course. Let's take our first super quick look at GitHub right now. So in a web browser, I'm just going to go to github.com and then From there, visit the particular repository or project that I want to work on. So here is the super advanced website. You will remember that name from the one we were working on earlier. So here's the GitHub overview page for this repository. You can see here are the files. Here's the index.html file that we edited earlier. You can even preview the code in the browser. But if we go back to the overview page and click on commits, we can see here are all of the commits in this project's history. And you will notice that the commit we made earlier in this lesson, where we made the text orange and removed a line, that's not showing up here in this list of commits. And that's because we committed that to our local copy of the repository, but now we need to take what's on our computer's hard drive, we need to take that Git repository and push it up to the server. So I will jump back over to my command line and I'll just type git push origin master. Again, don't worry about what I'm typing. We will learn about this in the next lesson. But for now, I typed that in. And if we go back to GitHub and refresh this page, we see here is the commit that we worked on earlier. And if I click it, we can see the details. GitHub even tells us you changed 2 files. And if we scroll down, it even highlights in green the lines of code that we added, and it highlights in red the line of code that we removed. Now, the only thing that I want you to absolutely remember from the last minute is that what we just did is called a push. We took the repository that was on our hard drive and we pushed it up to the server. So now the server is up to date and has our latest changes. Okay, so that's a push. What is a pull? Well, let's imagine that we go on vacation for a week, and while we are gone, our coworker makes a few updates to the website's code. So a week later, we get back from our vacation, we go to GitHub, we click on commits, and we see that there are 2 new commits from our coworker named John Doe. We can click on each commit and see what he did. So in this commit, he changed the heading to be about dogs, and he changed all of the bullet points to be about dogs. And in this other commit, it looks like he just swapped out a few new colors. Now, imagine that our boss asks us to remove the line of text about being very loyal. Well, the files on our computer for the website don't even contain the word loyal, because while we were on vacation, our files don't automatically get updated from the server. So what we need to do is pull in the latest changes from the server into our local repository so that we are working with the most updated files. So we head to the command line, and I'm going to pull. The keyword here is pull. Don't worry about any of the other syntax for now, but I'm just pulling in the latest changes from the server. We can see that the pull was successful. So if I go back to my web browser of my local copy of the site and I refresh, we see the color changes that our coworker made, and we also see this line of text that says is very loyal. So our boss wants us to remove that. So in our text editor, I'm just going to delete that line. Save it. That looks good. So now I want to stage that change. So let's do a git status. Yep, that's the only file that I want to add. So I'm going to do add it to the staging area. That looks good. So we want to commit that, git commit. Our message will be removed line about being loyal. And then now that that's committed, remember we want to push that to the server. So git push origin master. We will review this syntax in the next lesson, so don't worry about that. But we're pushing it. Okay, now if we go back to GitHub, click on commits, here is the change that we just made. And that wraps up the basic Git workflow that you would use on a daily basis. Let's review what we learned in this lesson. We learned what a repository is. We learned that nothing gets saved into Git's history until we commit. And we learned that before we can commit, we have to stage our changes or stage our files. And we also learned that working with a server involves pushing and pulling. So we learned quite a bit. Now, in our next lesson, you will begin to get your hands dirty. So I will help you install Git on your computer, and we will work on command line basics. This is where things start to get fun, and I will see you in the next lesson. Thanks for watching this excerpt from my new Get a Developer Job course. I hope you feel like you learned something, and if you'd like to check out the full video course, there's a link to it in the description. Thanks again for tuning in, and I'll see you in a new video next Tuesday.